Afternoon wherever you are, and welcome to today's exciting session, exploring carbon matching as a strategy in energy emissions reporting. Today's webinar is going to provide you with an overview of the nuances and objectives of carbon matching, the benefits and challenges associated with this type of procurement, and what its adoption actually looks like in practice. So we've got a lot of ground to cover today, and I'm going to quickly get us moving forward. I know this is our agenda for today, so I'm going to briefly just introduce us. Then we're going to have Alex walk us through the introduction to carbon matching. We're going to walk through the global carbon opportunity to carbon matching. We're going to look at carbon matching in practice, when it works best, and then we're going to set aside about 10 to 15 minutes at the end of this session to just do open discussion and Q&A. So as we're going through this session, feel free to put your questions into the chat, and I will be facilitating at the end. So if you put them into the chat, we'll be sure to circle back and ask them to the appropriate panelist as we move forward. Now, I know many of you have already seen this slide, but just sharing SEBA's antitrust reminder once more. And as we get into today's Q&A session, please remember that we are going by Chatham House rules. So won't spend too much time on this because really why you are all here today is to hear from our distinguished panel of speakers. So today you are going to be hearing from the following experts: Sarah Sophia, Senior Research Scientist at Resurity; Alex Foster, Sustainability Solutions Manager at Engie; Robert Threlkeld, Director of Global Energy Strategy at General Motors, who will also be joined by Brent Hollenbeck, the Chief Executive Officer at Timberrock; and Mark Turner, who is a partner at Baringa and will similarly be joined by his colleague Hannah Simmons, Senior Manager at Baringa. So now I'm going to go ahead and I will be turning it over to Alex to kick us off with some background on exactly what it is we mean when we discuss carbon matching.
Thank you so much, Carrie. So as we look at carbon matching, one of the things I'm going to start here is I'm going to go back and explain how the current system works so that we all have an understanding of what we're talking about and what this framework would influence. So the current system, and Carrie, we can go to the next slide here. The current system of Scope 2 accounting is essentially focused in two areas. One is location-based, where you look at your location and take an average emission factor based on that location and apply it to energy that you're using. And the other is market-based, where you're able to apply some thinking around a company's actual consequences of their actions they're taking in terms of buying renewable energy. So in the market-based approach, what you're able to do is look at a big gridded market boundary where there's wires that connect different grids. And so an example of that would be the US and a little bit of Canada as well is included in one gridded market boundary. So what that means is that as we're considering decisions within that gridded market boundary, a company is able to consider any actions that they're taking from really California to Maine, for example. And what that means in practice is, as we look at this equation that's currently on the screen, what companies will do is they'll look at their induced load of electricity that they're using. And then within one of those gridded market boundaries, they'll go out and purchase the same amount of renewable energy in terms of megawatt hours. And what this leads to is the equation that you can see where you can do your induced load of electricity minus that renewable energy that you're purchasing before you're actually applying an emission factor to it. So if we go to the next slide, I want to first say that this accounting system has been really great for getting us where we are. Before this accounting system was introduced, we didn't really have a carbon market like we currently think of it today. We didn't really have carbon neutrality as we think of it today. So this accounting has been really awesome for getting us from where we were, which was not considering carbon as much, to having a real lens and a focus on this as it comes to renewable energy and electricity. But this system does have a few limitations. So one of the limitations that you may have seen is that gridded market boundary is really large, and it's based on the idea that energy is transmittable within that gridded market boundary. So what you're doing is if you're operating in California and you go out and you purchase energy, say in Texas or in Maine or in other locations, what you're doing is assuming that that energy is entering the grid and then being transmitted in some way to you. And so you're essentially saying that I'm going to pretend that I'm using this renewable energy since it's within this grid and market boundary. In reality, what happens with that energy is instead of entering a grid and making sure it's transmitted all over the US or all over Canada to hit those different regions, what's happening is that energy is entering the grid at a local node and entering a hierarchy of energies that they have. And very likely it's coming in at the top and displacing an energy at the bottom. So your hope is that you're displacing something like coal with something like wind or solar energy, which would be a great impact on the environment to have that new source of energy. But what actually happens, or what can actually happen, is you can come in and be replacing what is mostly solar with more solar if you're doing development in the same area on top of each other. And so what you can see here in this graph I have on the screen is on the left side, you have what the action that we're taking at the moment. So we're looking at the load that you have, and then you're purchasing the same amount of EACs or RECs or something similar to kind of claim against in your inventory. On the right side of the screen, what we can see is the potential impact of that. So while that induced load had a certain amount of emissions associated with it, it's not true that buying the same amount of megawatt hours will always lead to the same amount of emissions reductions or avoided emissions from those actions that are taken. So this is now becoming a concern as we're rounding the corner of looking ahead from now we have a carbon market, now we understand carbon neutrality. The next goal is to make sure we get to a place where we reach a fully decarbonized grid rather than just 80-90% of it. So on the following slide, there's a couple approaches that we're looking at that are being suggested for updating this process. One you may have heard of is 24/7. Another you may have heard of, which is what we're talking about today, is carbon matching, which is supported by a group called the Emissions First Partnership. So I put them on this slide as well. And both of these approaches are aimed at the same goal. So how do we make sure that we are accounting more directly for the impact of actions and making sure that we're aligning that idea of what people are claiming on paper with what is actually happening in the environment? So as a really quick rundown, 24/7 is the idea that let's get way more specific with the grid and market boundaries and with time as well. So if you're using energy in San Diego at 3 p.m. or at 3 a.m., make sure that you're purchasing renewable energy in San Diego at 3 p.m. or 3 a.m., whichever that is. So that is aimed at reducing some of those variables we just discussed, which can make sure that those megawatt hours are more accurately aligned with the impact that you're claiming. The carbon matching approach, on the other hand, takes a little bit of a wider lens. So it zooms out and takes a one atmosphere approach, saying that as long as you can create a reduction of carbon into our atmosphere, it doesn't actually matter if it's in the same grid or market boundary. So being within that grid and market boundary is all about whether that energy is transmittable. But instead, if we focus on the emissions impact, then we can quantify the impact of energy entering any grid in the world and account for that as we think about one world, one atmosphere, and one effect from climate change. So one way to think about the relationship of these two is a little bit like the square and the rectangle. So carbon 24/7 is not necessarily the same as carbon matching, but a carbon matching approach will allow for 24/7. So doing that approach and limiting location and time will allow those emission factors to be really similar. And actually, if we go to the next slide, it might help a little bit more with this explanation. So what you can see here is the two equations. The first one is what we showed as the current system. The second is what we would be thinking about as it comes to carbon matching. So instead of taking the megawatt hours of your induced load and the megawatt hours you're purchasing, subtracting those and applying an emission factor, instead the idea would be to take your load and apply that specific emission factor, and then look at your renewable energy and find the avoided emissions through that specific emission factor. So applying an emission factor to each of those things relative to the impact that they're having, and then being able to net CO2 equivalent and CO2 equivalent rather than megawatt hours and megawatt hours, which can vary greatly as we talk about emissions. So as you can see, one thing that's great about this approach within carbon matching is if you want to go the route of a 24/7 and hyper localize the impact that you're making, that is totally fine. What will happen is those two emission factors will become the same because they're in the same time and the same location, which will then result in the same equation that we have above. You can do the math there and kind of pull out the emission factor and have the load minus the RE again if the emission factor is the same. So hopefully this gives you a little bit of a rundown of what carbon matching is. I welcome questions in the chat if anyone has any confusion still or wants to double click on any of this. But if we go to the next slide, the final thing I'll talk about is a few of the benefits that we see from carbon matching. So the first one is the idea that it can maximize the emissions reductions that companies or organizations can have with their purchasing power. So with that focus on avoided emissions and reducing the focus on the grid and market boundaries, instead of pouring that money into a place where it's cheap to develop, but maybe not having a big impact like West Texas, it will encourage organizations to focus on areas where they'll get a lot of impact for the investment they're making so that they can make big claims on their inventory. This will also lead to greater procurement flexibility. So instead of, again, drawing that grid and market boundary, it takes a one atmosphere approach. And this allows for a few things, but one that I'll highlight in particular is under approach that's more stringent on time and location. It can really be difficult to do procurement, especially if you think of one company that has lots of little locations all over the globe. So that would suddenly mean that that organization has to procure in lots of little locations all over the globe, which, as we all know, can be really challenging in terms of what's available and in terms of where the money is for your organization. This will allow for greater flexibility considering a one atmosphere approach. And so it'll allow that organization with lots of little pieces to pull that money together and make an impactful purchase with that same investment rather than lots of little ones that might not move the needle. It'll also enhance that emissions transparency. So that's really the root of this entire idea is let's get to a place where we're aligning real world impact with what we're seeing on companies' inventories. So really transparent there, which is great. And overall, that should hopefully improve stakeholder trust. So really appreciate you listening to the quick intro on carbon matching. We're going to hear next about some of those global opportunities. And as I said, feel free to throw questions in the chat. I'm happy to double click on anything I detail.
Brilliant. Thank you very much, Alex. And hello, everyone. We are very excited to share with you some of the findings of Baringa's work on carbon matching, and in particular, our recent corporate catalyst study. So if we can go to the next slide, please, Kerry. As we began this work, we posed the following question. What happens if businesses source clean energy wherever that saves the most CO2, rather than just in the markets where they operate? And to answer that question, we set about modeling global corporate power demand, clean energy sourcing, and scope 2 emissions out to 2040. And we did that at hourly granularity. I have to say it was a huge task, but without giving away the ending, it's fair to say that we were blown away by the scale of the benefit that we found. I think some important context here is that a lot of weight tends to be placed on climate targets, where success is measured at a fixed point in time. But how one gets to the target is also crucial. What matters from a climate perspective is the cumulative CO2 emissions over a period of time. And so that means the speed of decarbonization is really important. And that's where a global approach to energy sourcing can really win out. And so with that context in mind, let me hand over to Hannah, who led the Baringa team for this work. And Hannah's going to take us through some of the key findings from our study.
Thanks very much, Mark. Hi, everyone. So yeah, delighted to present some of the key findings from our report today. As Mark said, the key finding and really big takeaway from us was really just the level of impact that an emissions first approach can take to carbon reporting. So our study found that it could save up to 1.7 billion tonnes of carbon dioxide over the next 15 years, which is just a huge number. It's the equivalent of taking about 40 million cars off the road today. But also, more importantly, as Mark said, that acceleration of global power sector decarbonisation by 18 months. So the way we looked at this is we looked at, we have an in-house view of how we expect power sector decarbonisation to occur over the next 15 years. And we effectively applied an additional decarbonisation rate that looked at where is corporate demand for renewable power today. About 80% of PPAs are signed in Europe and the Americas. And what if those PPAs and that demand for renewable power shifted to markets that had the highest emissions intensity? So you basically see a shift from Europe and the Americas to places like India, Malaysia, Vietnam, South Africa, Poland, where you've got much higher emissions intensity grids. So, for example, you might see a corporate located in the UK, that's where we're from, where it's about 90 kilograms of CO2 per megawatt hour emissions intensity, shifting to some of those high emissions intensity markets where it's more like 750 kilograms of CO2 per megawatt hour. And that shift just really allows you to drive this accelerated decarbonisation of the power grids and deliver this impact over the next 15 years. I should also add that this is also based on about 325 terawatt hours of corporate demands. We took quite a conservative approach based on the RE100 members' demand for renewable power today. But also we looked at expanding this. So what if you took a more optimistic approach and actually increased, roughly doubled that demand for renewable power? And we saw a pretty linear relationship between it. So again, you kind of double that impact to roughly 3.2 billion tonnes of carbon dioxide over the next 15 years. And what this shows is it just shows the scale of coal and the dominance of coal in our power sector today, that still remains and is expected to really remain going forward. And actually, if you can, any impact you can drive to accelerate the shift away from coal has a huge impact from a global perspective. But what is this really showing in terms of renewable deployment as well? I don't know if you could just move to the next slide. So our study is based on the deployment of around 90 gigawatts of solar, 50 gigawatts of onshore wind, and about 15 gigawatts of offshore wind. So this was really kind of looking at what the opportunity was in these different markets. Obviously, offshore wind isn't appropriate for all markets, and the opportunity for solar and onshore wind differs. So we took that into account. So you can obviously see, still you get the vast majority of solar deployment, about 90 gigawatts, but the opportunity for onshore wind is also significant across these markets. And again, if we move to the next slide, that increased renewable deployment is predominantly displacing coal still. It's not until you get up to sort of 1,500 terawatt hours of corporate demand where you start to see gas being displaced on the system. So that's the equivalent of leaving about 825,000 tons of coal in the ground, which is just, an unbelievably huge amount of coal, and that's really what's driving the impact here. And the story is pretty consistent. The more we can displace coal, the greater the carbon savings, and that really needs to be where our focus is. You can also see on the pie chart on the right-hand side that actually 80% of the impact is also concentrated at about 5 markets. So that's India, Vietnam, South Africa, Indonesia, and Poland. And again, a lot of this is driven by coal on the grid, but also the scale of demand on those grids. There is so much demand in these markets that the opportunity for renewable deployment to continue displacing coal is great. It is very significant. The other thing that helps in these markets in terms of the decarbonisation impact is they've got relatively low levels of renewable deployment today, which means that obviously any additional renewables you deploy, you are displacing coal off the grid. You're not running into issues of curtailment and things like that, which actually means that, whilst storage technologies, flexible technologies obviously have a really important role to play, actually in these markets, it's just about incentivizing more renewable deployment on these grids. And if we could just go to the next slide as well, please. And what does this look like from a financial perspective and a financial standpoint? So obviously, as I've said before, a lot of that investment is coming out of Europe and North America and going towards Asia Pacific, Central and Southeast Asia, predominantly those markets that I've already mentioned. But also the other really interesting finding for us is because each megawatt of renewable deployment has such a bigger impact on decarbonisation, you actually significantly reduce your costs. You get much more kind of bang for your buck. So the cost of decarbonising the grid goes from about $135 per megawatt hour per kilogram of CO2 down to about $65 per kilogram of CO2. So, it's not just kind of a more equitable way of decarbonising the grid globally. It's also kind of much more efficient from a financial standpoint because you just get a much bigger decarbonisation impact. The other important thing to mention is also, a big conversation on the world stage is about an equitable energy transition and how do we drive investment from more developed economies through to emerging and developing economies. And actually, we see this as a great opportunity to shift that level of investment through to some of these more emerging markets that have kind of, quite frankly, been left behind in the energy transition today. So we see about $85 billion in investment being directly redistributed from developed to emerging economies, which is more than the total foreign direct investment made into India, Indonesia, and Vietnam combined in 2022. So you can see just the sheer scale and volume of reinvestment and the impact that can have is hugely powerful. And then just moving to the next slide. Great. So if you'd also like to hear more or listen more, we've got the full report can be found on Baringa's website at baringa.com. And we've also got a podcast where we sit down with Faraz Ahmed from Amazon to discuss our findings in our report in a bit more detail. It's about 25 to 30 minutes long, so perfect for morning commute listening. I think I'll hand over to the next presenter.
Yep, and that will be to both Rob Threlkeld and Brent Hollenbeck. So I'll kick this off a little bit, and this kind of builds off of the Baringa conversation as well as we kind of think holistically, the Earth. And really, it starts to build on the other element as we diversify and really electrify the transportation sector. And so if you think about that, some of this predated even the early days of renewables and EVs as we started to think about how do EVs and renewables integrate together in a solution that drives, systematic reduction in carbon in the grid. And so as we can see, this actually preludes even some of the renewable energy RE100 efforts, or even our RE100 goal as itself. So really, phase one was kind of a definition phase back in 2013 as we're, really in the middle of the second launch or the second generation of the Volt and before the Bolt launched, of looking at ways to pilot various next generation energy optimizations into the efforts of what we do, both from a carbon matching perspective and virtually coupling that with our renewable energy efforts and EV efforts that we've been doing as a company. Phase two really started to, as we looked a little further into advancements, and we actually announced our RE100 goal in 2016, was reviewing peer research to gain confidence in what we were concluding through our own pilots is actually working. So we actually piloted some of these efforts early on in the early stages of our e-motor facility in White Marsh, Maryland, which had on-site solar as well as on-site battery storage, and was the launch factory of the e-motor that went into the Volt. And we were able to kind of articulate how V1G or vehicle to grid elements could play into the efforts of on-site renewables, which think globally you could scale as we started to scale corporate procurement plays into this effort. Phase 3 really got into what I would say the data analysis phase, which working with Watt Time early on around the marginal emissions data, working in this case PJM, that was the ISO that was supplying the facility in our White Marsh facility, ultimately led to their publication of the marginal emissions data. I mean, we were kind of pushing this early on, saying, hey, this type of data is very useful to us as we think about it from a corporate procurement of renewable energy, as well as our transportation, electrification elements of a company, and how this really plays into this could be a benefit to the grid as a whole. And then phase 4 is really developing a purpose-built software platform for the execution of our next generation energy optimization efforts. So what we've really worked closely with Timberrock, and Brent will really be getting into this, is a way to automate and provide an audit-ready collection and calculate our matching of and export of our emissions data real time, looking at our facilities, both what we do from a corporate procurement perspective, from a load profile perspective, from a grid perspective. And then we've been scaling this beyond, obviously, our renewable efforts into how this plays into the transportation electrification sector as we think about the benefits that EVs bring, specifically around vehicle to grid, and balancing out the efforts of decarbonizing both transportation and addressing the intermittency components that both renewables bring to the grid. So Brent, I don't know if there's anything additional you wanted to kind of talk to on this, since you've been in this in the early phases for well over a decade with us.
Yeah, sure. Thanks, Rob. Yeah, I'll add some flavor just to make the point that the journey that Rob just kind of ran through, as he said, was over a decade long. Spoiler alert, I think for anybody listening on the call, it doesn't have to take you a decade to do the same. I should note Rob and I were 15 when this all started. But just look for a second at the 4 phases that we're showing here on the slide. It's really defining what is possible. How can you align clean energy supply and demand in real time? The research that many organizations have done that have pointed in the direction that this has a high impact. We've heard some research just today on this call. And then fundamentally the availability of the data, and then how do you use that data in real-time systems? So think of us, the work Rob and I have done on this with GM and Timberrock is kind of from a very practical perspective, kind of just working our way through. How is this going to be done? How can this be accomplished? But if we go to the next slide, we'll talk for a second just about a quick snapshot of what this ends up looking like over that, kind of where we're at today through that 10-year journey. So what you see here represented is that, again, the focus here is on emissions first, understanding where the renewable energy generation is, what are the avoided emissions, what did that renewable energy project displace in the way of a marginal generator, and then wherever your load is, what are those induced emissions? And as was made very clear by a prior presenter, it's really critical where you site the renewables to have the biggest impact. But one of the things about the matching part of emissions matching is that you're also looking at your load and you're trying to flex and conform your load so that it takes energy from the local system when it's as clean as possible. So this is both a supply side and a demand side equation that you're balancing. And as Rob indicated, we're doing this in real time. So as we worked through the journey, where we ended up was a comprehensive energy data platform that is connected to most all of GM's major facilities, over 1,300 individually metered energy assets that are being tracked in real time, many large-scale PPAs, assets to include workplace charging and pilots and demonstrations we've done, all the way down to GM dealerships, all the way down to GM EV. So it's a very comprehensive approach that's been applied. So if we go to the next slide, again, as I said earlier, spoiler alert, you don't have to take a decade to do this. If you think back to the 4 phases we defined, It was defining how this can be done. Well, Alex just shared that with us at the top of this presentation. So the things that were unclear to Rob and I a decade ago are now clear. There's organizations that have spent a lot of focus and time on defining how this can be done. One of our other presenters just presented some research, and there's many, many more peer-reviewed research out there that can confirm the veracity, authenticity, the efficacy of this approach. So again, check box, that's there. You don't necessarily have to wait for that. Just there's lots of studies. We're glad to point you to all that work that's out there. Thirdly, you might be saying, hey, well, this depends on data, right? How do we get all this data? Well, the marginal emissions data is available from in some cases, the ISO themselves, others from folks like Walk Time. Research is on this call. They'll talk about how they make data available. And then getting your load data and renewable energy generation data integrated in real time is possible as well, as we've just demonstrated or talked about with GM. And then finally, again, our approach we took with GM is that we had to build a purpose-built platform to connect those three things, the methodologies, the data, put it all in one place. And that's available now too. So again, think of some of the work we've done is providing a roadmap or the breadcrumbs that allow others to follow along quickly. So maybe we can go to the next slide and Rob, I don't know if you want to highlight any of these key takeaways, and then I'll chime in.
I think the key the first one really up there, it is around the 3 C's: cost, carbon, and confidence. As we think about the cost of business and procuring energy or potentially going to decarbonize in transportation sector, how we address, our sustainability targets and goals around carbon, and then confidence. How do we ensure that what we're doing is actually driving true? And as we've seen, I think with previous presentations as well, confidence in what we're doing actually is reducing carbon and reducing costs. I think that was eloquently articulated as well, that there's a cost benefit associated with this if you look at this in a very holistic, systematic level. As Brent noted, it is really a supply side, demand side, real-time action. Everything you do, you have an input and an output. How are you making those decisions on a real-time basis so that you're also reducing carbon and reducing your risk and exposure from an energy profile perspective? And then maybe, Brent, I'll let you kind of take the last two data points here.
I think our goal here is to try to lay out that you can just get going on this if you want, so as not to make it complicated. The one thing I'll point out, though, is we call it a data tsunami. You're measuring all your load, all your generators, lots and lots of energy assets in real time. That's a ton of data, billions and billions and billions of data elements that we track currently across the GM footprint. So be prepared for a data tsunami. That's why you do need some tools and platforms and solutions just to manage the data. The last point I'll make is that there's, we already, Alex mentioned earlier, sort of, let's call it the two camps of 24/7 CFE and emission matching or emissionality. I would just make the point that both of these approaches, if you're thinking about which one might be right for you, I think they're much more common than they're different. And from our perspective, as Alex already said, the same tools you would need to execute one sort of support the other as well. So again, just get going would be our guidance or our suggestion to you. Start building tools, getting your data in order, irregardless of what approach you might ultimately adopt. And with that, I think we'll hand over to the next presenter.
Great, thank you. I'm going to talk a little bit more about kind of when carbon matching works best, and how kind of a few different scenarios and case studies kind of show the impacts of using carbon matching to maximize decarbonization. Go to the next slide. So as previously mentioned, in order to maximize your impact, you really have two levers with carbon matching. So you can, of course, increase your impact of your clean generation, as well as thinking about load and how to minimize the impact of your load. So minimize your carbon footprint while maximizing how much carbon your clean generation is avoiding. You go to the next slide. And so carbon matching, I'm thinking about when it works best. We really want to think about when there's variation in emissions rates that we can take advantage of. So that comes from two different places. So on the grid, if you have a lot of variation in spatially and temporally in your emissions rate across whatever region you're looking in, that exists for you to take advantage of. And then additionally, if you have the ability to kind of exploit those variations. So if you have kind of operational decisions that you can make based on the location of your renewable generation, siting it in places that will have the most impact, and also citing your load where it's going to have least impact. So if there's that kind of extremes, the more extreme your variation is across the grid and your emissions rates, the more you can leverage that to decarbonize most effectively. Additionally, if you're able to adjust your load, so load shift to times when emission rates are low and reduce load when emission rates are high, these are kind of the ways you can take advantage of the existing system to minimize your emissions rates. Hourly matching, on the other hand, potentially works best when there is less variation. So if emissions rates are pretty consistent across whatever region you're in, or if you have co-location of your generation and your load. So like as previous speakers mentioned, these carbon matching and hourly matching can be kind of synergistic. They can kind of align as long as you're using them in cases that make the most sense. So if the conditions are right for hourly matching, can potentially work similarly to carbon matching. So if we go to the next slide. So to kind of explore kind of the potential opportunity that exists due to variation in marginal emissions rates, we look at Texas. ERCOT has a lot of variation across the grid due to it having a large penetration of renewable generation that's fairly unevenly distributed around the state, and that drives a lot of congestion within the area. And so you can see here on the right is the average marginal emission rate across ERCOT. You can see there's a lot of separation. In West Texas, marginal emissions rates are quite low, where there's a lot of renewable generation with limited capacity for transmission to export that to other areas of the grid. And so we see there's a lot of variation across just one market region. And so let's kind of take a closer look at this and explore potential opportunities for using carbon matching in ERCOT. Go to the next slide. So to start with just a baseline scenario, if we assume you have a load in Houston and procured power from a wind farm in West Texas. And for this case study, we're just going to assume the load is flat and your wind farm and your load are annually matched. So you have the annual generation produced from your wind farm is the same as the total load the total energy used by your load. And if we look at the actual marginal emissions rates using locational marginal emissions rates that we have at maturity, look at the emissions induced from your load in the brown bar here, and then the emissions avoided by your wind farm in the green bar. As you see here that the avoided emissions are much less than the induced emissions from your load. So you actually have a pretty high still net emissions despite kind of having equal generation in your renewable equal generation to your used energy. And that's because wind farm is located in an area with quite low marginal emissions. And so it's just not having the same impact as your load is. So if we kind of want to try and address this, potentially we can think about resiting your wind farm. So if you go to the next slide, if we instead procure power from wind farm that's in North Texas, where the marginal emissions rates are much higher, the impact of your wind farm is much greater. So this green bar has grown a lot. So now we're basically netting out your induced emissions from your load and your avoided emissions from your clean generation because you're able to have kind of a similar profile of your marginal emissions rate at your load and your wind farm. And if we now take one step more, we can do a little bit better. What if we were able to site load in a different location? If we go to the next slide, if we instead moved load to an area where marginal emission rates were low, so move your load to, say, West Texas, where there's a lot of excess renewable power that you could take advantage of, would reduce the impact that your load has. And so you can see this brown bar of the emissions from your load is now reduced, meaning your net generation, or your net emissions is now negative. So you're avoiding more emissions than you're inducing for the same total used amount of power by just moving around to siting your load and siting your procured power in places that maximize their relative impact for carbon matching. And if we go to the next slide, and so this obviously just looks at Texas, but if we look beyond just a single ISO and confining ourselves to a single market boundary, This shows the marginal emissions rates average for 2023 across the whole US. You can see there's much more variation if you expand beyond that. And if we want to maximize decarbonization, we can try and see how we can take advantage of that. So we can see, like, for example, in California, the grid just generally is much cleaner, much greener, so emissions are lower. And in parts of the Midwest, emissions rates are much higher. So if we think about siting our load where the grid is cleanest, just to reduce the load's impact as much as we can, and site renewable generation where it's the dirtiest, we can much more effectively decarbonize. So we'll just look at another case study, looking at load in CAISO and citing a wind farm in MISO in Michigan, where it will have much more impact because it's displacing much dirtier power. And so if we do have a similar analysis that we did in Texas, you can see now that the impact from your load, the induced emissions from your load, is much lower because it is operating in a greener grid that already has a lot of renewables. And the impact, the avoided emissions of your wind farm is much, much greater. And so this ends up with a significant negative net emissions. And you can actually see you're avoiding more emissions net than your load on its own is inducing. So by just expanding the possibilities for where you want to site your wind and your load, or any clean generation in your load, you open up opportunities to much more effectively be decarbonizing by taking advantage of the variation that does already exist on the grid. If we go to the next slide. And so since we're talking about kind of these variations and extremes, I want to talk about, like, why we see that and what we expect the trends to be. And so the energy transition is really creating a lot of the variation on the grid that we see in emissions rates, because the rate of build out of clean generation is very varied in different regions. And so you can see, for example, in the prior example, California has built renewables much faster. So that grid has had a much faster reduction in its overall emissions. And so you kind of get these variations as the rate of building renewables varies in different regions. And we also see a lot of uneven distribution where renewables are built. So like in Texas, you get these pockets of a lot of renewables being built that drives increased congestion. And so that causes more variation in even smaller regions. So like within a fairly confined area, there's significant variation. And so the energy transition is a really great opportunity. Like, as we're doing this, we're seeing these extremes kind of grow. You can see these figures here from 2018 to now in Texas. Because of the increase in renewables, you see more and more kind of variation in pockets of high and low emissions. And of course, as we continue and decarbonize the grid further, some of these variations will start to collapse as the grid as a whole becomes cleaner, which is what we're all hoping for. But targeting areas with high emissions rates for where you build your clean power and putting your load in areas with lower emissions can accelerate this process to get to low emissions everywhere quicker. And these case studies focus on location, but of course, time is also a really important factor as well, where we see times of day that have lower emissions rates than other times due to the variability of wind and solar power, variation in demand. And so when you have the possibility to load shift, this opens up another opportunity to have impact and reduce the impact of your load. And so you can see here, this is PJM diurnal shape of marginal emissions rate, where the emissions rate is higher during the day and lower in the evening. So if you can shift some of your load to evening hours, that can reduce your impact. And one thing that is worth noting is we see this higher emissions rate during the day, that if you were to hourly match and shift your load to match a solar plant, for example, this could potentially increase the overall emissions of your load because you're shifting to hours when emissions rates are higher. So it is really important to consider what signals you're using to shift when you're using power to make sure that they are aligning with your goal of reducing emissions as your primary objective. So if you go to the last slide. So just, summarize, we can see that when there are extremes in variation, or really just any variation in emissions on the grid, it really opens up a lot of opportunity to harness that variation to maximize your decarbonization. And considering where you're siting renewables as well as siting load is really vital to that and can help accelerate the rate that we decarbonize the grid uniformly and make a much bigger impact with similar investments in renewables, so we can reach cleaner grid more quickly. Thanks. And that's
okay. Well, thank you, everyone. Thank you to all of our incredible speakers today. Just briefly showing the disclaimer slide on here. Let's see if I can get my computer to show you that. Wonderful. We are now going to open up to our Q&A session of this. So I'm going to go ahead and stop sharing my screen so we can see all of our panelists as we ask our questions. I had a list of questions, but all of y'all are so strong that I think we're just going to go ahead and hop in. There's a couple in the chat and in the Q&A, so I'm going to go back and forth, so y'all bear with me, but I think we'll probably be able to get to everything, but let me know if there's any that I missed. So first and foremost, I'm going to kick it off with our Q&A question, and this can be directed to anyone, but it first came in within the overview to carbon matching presentation. So Alex, I'll ask you maybe to kick this one off then. Wouldn't carbon matching encourage renewable developers to build near coal plants and then do everything they can do to make sure that the coal plant does not close? Because if the coal plant retires, then the marginal emissions reduction of the solar asset goes down, and thus the value of the project.
Yeah, it's a great question and something you have to consider as you're planning out a new system that will affect how people are not only developing energy, but they're also putting investment into that energy and procuring. So the idea of the system is that you're constantly looking for areas where there will be the next kind of see how that varies based on time and location. The idea of keeping the coal plant running so that you can have a lower marginal emission. What that would mean in the flip side would be that you were producing not enough energy to make an impact on the marginal emission rate of that location. So the idea is that you would come in, you would build a plant next to that coal plant, you would start to produce energy, which would lower the marginal emission rate. And then the more energy you're producing, the lower that marginal emission rate is going. So you would have an inverse curve really of your demand from the profit that you're getting from the energy you're selling with this idea of keeping a coal plant open, which in reality wouldn't become cost effective. So that's my quick answer. I'm happy to go into more detail, but also welcome any other panelists if they have more details to add.
I do think it's a really interesting question, and but in a sense, it's not a new concept, because if you think of the kind of revenues that a wind farm or a solar park is earning in any market now, that is affected by what happens in that market, how many other wind and solar generators there are, and of course you're the first person to build a wind farm, you're making a great revenue. More and more wind farms are built, you get that value being to some extent cannibalized. Of course you might want to stop other wind farms being built, but that's not how it works, and it's not how it's working now with with renewable build out. So I actually think it's not a new concept that you get that impact in a market.
I'll add briefly just to say I think that's one of the key benefits of emission matching, is that it pulls how you account for carbon and how the energy markets work a little bit closer into alignment. So yes, when you build a renewable PPA, you don't know what the LMP is over the long term. You're taking some risks there. You also don't know what the long-term LME is going to be either, but it's the same thing really, right? So it is a risk, but I think it's a risk that on the financial side, is understood. It's now just kind of aligning how the carbon accounting is done and then how the financial accounting is done for the project.
Great. Now turning to our top question in the chat. How do prices for EACs in the emerging markets generally compare to the cost of RECs in North America, or is it not so straightforward to represent? Also, are the clearinghouses that track and retire the EACs in emerging markets adequately rigorous and credible?
Yeah, I can jump in on that one. So I think that obviously the price of EACs vary, depending on the market. I think we've experienced in the UK certainly a significant rise in the price of our equivalent, which are REGOs, renewable energy guarantees of origin. So obviously the leaving of UK from the European Union, ending supply, meant that the revenue from those went up significantly. Obviously within the international standard, you've got a much larger market boundary. But I think the point around kind of the credibility of the accounting system is a really important one. I think that's something that we've seen as a big challenge for corporates and companies across the world in markets that have less robust data and accounting methodologies and systems, because it is much more challenging to demonstrate that an additional kind of megawatt of solar equates to a carbon saving. You know, the accounting in Europe, North America, more developed markets is much more kind of robust with those accounting standards. It's a lot more challenging in some of those other markets that are kind of adhering to the IREX standard.
Awesome. Thank you, Hannah. Does anyone have anything further they want to add on that question? Great. Then I'm going to turn it back to the Q&A. Are there emissions reductions calculations based on short-run marginal rates? Any risks with using that over something else, aka average or long-run marginal instead?
I'll jump in again because I guess in terms of the study we ran and the way we modeled it is we did look at the short run marginal emissions factor. So we effectively looked at what was the kind of hourly generation profile of a solar or wind asset in that region, and what would be the kind of average generation mix in those markets for each hour of as well, to get kind of a robust view of what are you actually displacing in each hour of each day in each market to calculate that emission saving. But obviously, you know, there are markets are more complicated than just that. And there are other factors to consider. But I think if you stand back and you look at the findings of the study, what it shows is just the sheer kind of scale of the impact. Obviously, there are other enablers that need to happen alongside this. We need transmission infrastructure to be built out. We need more investment into, you know, really in terms of that supporting infrastructure, getting those electrons where they're generated to where they're needed. But if you look at the scale of the impact that emissions first reporting can have, you know, that's where we should be focusing, you know, that displacement of coal. So, you know, as I said, we did take a short run marginal emissions approach, but I think that captures, and the key findings of that captures an awful lot of the scale of the impact that you can deliver.
Yeah, and I think just to add to that, yeah, our analysis also is short run, and I think it's important to consider when you're thinking about emissions impact, it's the combination of short run and these like longer run build impacts. And so I think, of course, it is definitely important to think about those. But if, again, thinking like transmission, by building in places that strain the current transmission grid less, I think is a clear path to like improving the rate that we decarbonize, especially given the challenges that we've seen in getting new transmission built. Of course, there is definitely possibility that, you know, depending on how pressures on the grid kind of incentivize changes to transmission infrastructure, affect long run impacts. I think that's worth thinking about, but certainly I think the short run impact still is a very, very important part. And like Hannah was saying, like the sheer magnitude, I think, is really telling.
We've got a number of questions. I'm going to keep us moving forward, being aware of the time. Can we imagine a scenario where the greenhouse gas protocol incentivizes this type of behavior or investment?
I can jump in and take this one. So yes, this is definitely in consideration for the update process of the Greenhouse Gas Protocol. For those who don't know, the Greenhouse Gas Protocol is currently undergoing their own update process for Scope 1, Scope 2, and Scope 3. And as a part of this, there's a big conversation around Scope 2 as to what does the future of this look like. So there have been direct conversations with members of WRI who put forward the GHG protocol, as well as conversations within those working groups that are coming together to talk about what does this actually look like? And those conversations are revolving around some of these ideas being put forward, carbon matching and 24/7 in particular. So yes, there is definitely a world where this becomes incentivized by the Greenhouse Gas Protocol. And I would expect those changes, I would expect that there will be changes no matter what they are, and that those will probably go into effect around the end of 2026. Just a pure guess from my part.
I think I'd also add on that, I think, to Alex's presentation at the start, if we roll back the clock to when we just had locational based reporting standards, that really limited what corporates could invest in. The whole point of introducing market-based emission standards was to try and encourage and drive more investment into renewables, because at the time, back in 2015, I think it was, renewable penetration, we were much earlier on in the process. And I think if you think about it now, we're, getting on for 10 years on for that. It's kind of like, what's the next stage? What's the next type of behavior we need to incentivize? We've had great success in building out more renewables in grids across the world. And now it's kind of saying, okay, well, what's the next wave look like? And I think particularly when you think about the two standards together, they have different purposes. I think emissions first, what we're talking about today, is really about kind of driving that investment into grids where there are higher emission factors. But there's also that role for hourly matching in places where they are more constrained. And it's about kind of serving both those purposes going forward as well.
Great answer. Turning back to the Q&A, isn't there incredible uncertainty in long-term LME? Are we expecting VPPA customers to assume LME risk when they sign 20-year PPAs, and have you talked to corporates about this?
Maybe I'll give a couple of words on that. I think it's a really great question. There is uncertainty for sure. And we spend a lot of our time in the team at Baringa sort of crystal ball gazing 20, 30, 40 years ahead. And like the range of uncertainty around some of that is enormous. So, the swing factor around, carbon intensity 10, 20 years out is big. I think this comes down to the implementation of some of this and how corporates are measured, how their performances are measured and incentivized. And I think that needs to be done in a way that doesn't load a lot of risk onto corporates that they're not best placed to deal with. And in particular, I'm quite passionate about this being accessible to a broad range of corporates. So, I mean, there are some corporates that can afford to avail of Baringa's services or those of others and get long-term projections. But actually, that's quite a rarefied bracket of corporate buyers. And we need action to be accessible to a full range of buyers that don't have the deepest pockets. So I think, not requiring that 10, 20 year look ahead and not requiring corporates to take on that risk, I think is an important tenet of how this is implemented. So I think when it comes to the design of the protocol, I think that's for me a key factor.
Yeah, I can jump in there, Mark, as well, and add that, in the current setting, we know that there's already risk associated with PPAs and VPPAs when you're doing 20, 30-year contracts. We have no idea what that will look like. And so we do all build models to try and estimate what that will look like. And I think that we will continue to do that and get better and better at it. And I think that there wouldn't be a world where we would ask people to take on too much risk without the right data in place. But that being said, I will say that the forecasting of these things in PPAs, VPPAs didn't really exist when the Scope 2 guidance was initially created. And so all of these things that you're thinking of are really within the realm of fitting with the system and making sure that it works for corporates. And that lens of this, I don't think will ever go away. So whatever system that we move forward with, there will be a keen interest to make sure it aligns with corporate goals. And the final thing that I'll say is that this idea of carbon matching and the emissions first partnership is extremely rooted in procurers and people who are buying energy and corporates. So there has been discussions and there's lots of conversations still, and there are lots of supporters for this, just to answer the second part of that question.
And I know we had a few more questions in the chat, but I also want to be aware that we have bumped up against time. So first and foremost, just want to thank all of our wonderful experts for sharing their insights and knowledge with us here today. We will make sure that this video is readily available on the STIBA website afterwards, but if anyone would like follow-up to their questions, please feel free to reach out to me and I will be sure to coordinate with our panelists. But with that, I hope everyone has a wonderful rest of your day and thank you for your time.
Thank you all so much. Really appreciate you listening.
Thanks, everyone.
Thanks, everyone. Bye.